Hello guys, and welcome to another video. In this video, we're going to be solving Save the Prisoner. A jail has a number of prisoners and a number of treats to pass out to them. Their jailer decides the fairest way to divide the treats is to sit the prisoners around a circular table in sequentially numbered chairs. A chair number will be drawn from a hat. Beginning with the prisoner in that chair, one candy will be handed to each prisoner sequentially around the table until all have been distributed. The jailer is playing a little joke though. The last piece of candy looks like all others, but it tastes awful. Determine the chair number occupied by the prisoner who will receive that candy. There are 4 prisoners and 6 pieces of candy. The prisoner arranged themselves in seats numbered 1 to 4. Let's suppose 2 is drawn from the hat. Prisoners receive candy at positions 2, 3, 4. 1, 2, 3. The prisoner to be won sits in chair number 3. We're then given our function to complete below, which is going to be called Save the Prisoner. It's going to have the inputs n, which is the number of prisoners, m, which is the number of sweets, and s, the chair number to begin passing out the sweets from. Input format, we're given t, which is the number of test cases, and then the rest you already know. And then our constraints here is that t is going to be from 1 to 100, n is going to be from 1 to 10 to the 9th, and we don't really, you can use an int here and it should be fine. So to solve this problem, I went ahead and I whiteboarded the problem just because I thought it was interesting. And everything in this problem is just a shift away from 1. And you can clearly see that when you actually solve the first sample. That the rest of the problem depends on your shift away from 1. So if s is 1, we have our base case. We know that if we take the number of candies mod the number of prisoners starting from chair number 1, then the mod is always going to equal the chair number, all right? However, if we shift away from 1, then that shift we need to account for, which is just the offset, okay? So let's go ahead and take a look at this first. So in this case, we have 5 prisoners and we have 2 pieces of candy, and we start counting from chair number 1. So we have 5, 2, and 1. We have our chairs. I'm just going to go ahead and use squares for this. It's supposed to be in a round table format, but don't worry about it. It should be fine, just not doing it this way. So we have 1, 2, 3, 4, 5. Okay, so we start counting from chair number 1, right? We have 2 pieces of candy, so we have candy 1 and candy 2. We can clearly see that the person or the prisoner that we should want is going to be 2, right? So why is that so? We know that if we take the number of candy, which is going to be 2, and we mod that by the number of prisoners, then we get 2, which is going to match this guy right here. Okay. So the only time that we need to account for anything else is if the number of candies is a factor of the number of prisoners, the number of chairs. In that case, we are going to get 0. However, 0 just signifies that we're at the chair that divides evenly with the number of candies, right? Because we're modding it, and anytime we mod something, we get 0 to that number minus 1. So for example, if we were taking mods of 5, right, we get 0 to 4. However, 0 just represents 5, right, if we were looking at conversion for this problem. So with the base case, we know that if we have the number of candy and we mod it, then we should get the specific chair that we're looking at. So what happens if actually s is greater than 1? Right, so if we have like 2, 3, 4, 5, 6 or something. All right, so we know that to be fair, we need to start from here, right? We need to start from 1. So in the second sample, we have 5, 2, and 2. And so we start counting from the second chair, right? Because s is equal to 2, so we start counting from here. So we're going to go 1 and 2. So in the case that we had 2 pieces of candy and we had to start from chair number 1, you can see that we got 2, right? which is the same as the number of candy, whatever we mod to get the number of, for the number of candy with the number of prisoners. However, in this case, we're actually shifting the place where we start by 1 because we're starting here, right? And the distance away from where we should normally start from is going to be 1, which is going to be 2 minus 1, right? Which is going to be 1. So we know that if the number is greater than 1, right, all we need to do is take, so what we're going to do is take S, right, minus 1 plus the number of candies. And that should tell us exactly where we should be. So in this case, for 2 pieces of candies, we're at 3 because we shifted 1 unit to the right, all right? We shifted 1 unit to the right because we're starting here. Away from 1, we have 1 unit away from 1, and then we have 2 pieces of candy, so we have 1, 2, all right? So to actually account for that, what we're gonna do is we're gonna say, okay, hey, we have 2 pieces of candy. We have 2 pieces of candy, and we're starting from 2, right, for the chair number. So what we're gonna do is we're gonna say 2, right, minus 1, which is gonna give us our 1 unit away from the base case. So in this case, it's going to be 1, right, plus the number of candies, which is going to be 2, is going to be equal to 3. All right, so now if we take 3 mod 5, which is the number of prisoners, then we should get 3 for where we're supposed to be. And in fact, we do get 3, right? So I hope this makes sense here. So let's go ahead and look at the other problem. But you know what? Let's actually just go ahead and program the base case here. All right, it should be fun for the base case. So for our base case, what I'm going to do is, what should I do? So for prisoner, let's just create a variable for prisoner. Let's call this P here. And for the base case, we can say that if, right, S is equal to 1, right? So if S equal to 1, we know that P is going to equal M, right, mod N. However, there's a case where if, let's say, the number of candies or the number of sweets is a factor of N, then we're going to get a 0. So in this case, we got to take care of representing 0 as the actual chair number because we don't have any chairs starting from 0. So in this case, we can return P is equal to 0. So we're going to check to see if P is equal to 0. If P is equal to 0, then we have to return N because whatever number gave us 0, right, is just a factor of N. So that's the other reason why we get 0. So the chair number that we should return is going to be N. So now, if it's not 0, that means that we're actually at the right chair number because it's going to be between 1 and N minus 1. Okay, so in this case, we just return P. And this is for the base case when S is equal to 1. Now, if S is not equal to 1, then it's just going to be the shift away from S. All right, it's going to be whatever distance away from S that we start from. So you can take care of that, which is going to be, so in this case, P is going to equal to, right, M plus S. So remember that it's going to be the number of candy plus the starting position of the chair minus 1 because our base case starts from 1. So anything else that is not our base case is just a shift away from 1, all right? And then we're going to take that mod N, which is going to be the number of prisoners. And then we can return, which is just the same thing here. So pretty much we can just copy this here and it will be the same thing. So in this case, we just check P is equal to 0. And if it is, then we're going to go ahead and return N, else we're going to return P. Okay, so this is pretty much the problem. What I'm going to do is before I submit this, we're going to go ahead and work through this one. And so it's 373. And let me just kind of erase You know what? I think I can let me just erase all. Okay. So we have, it's going to be 3, 7, and 3. I was going to do 19 one, but that 19 is too big. So we're going to have 3 prisoners. And we have 7 pieces of candy. And we're starting from 3, right? So we're going to do, so it's 3, 2, 1. So in this case, what we're going to do is we're going to start here, right? So we're going to have, we're going to start counting from 1. So I'm going to start here. So let's say 1, and then 2, then 3, then 4, then 5, then 6, then 7. So clearly you can see the reason why I did this was because I wanted to show you guys that we have an offset of 2, right? Because we're going to have 3 minus 1 is going to give us 2 here. So that's the reason why I kept this blank here, so we can see that. So in this case, we know that we are 2 units away from where we need it to be, right? So in this case, we know that we are 3 minus 1 unit. So remember I said S is our base case, and if we have S as 1, then whatever we mod is going to give us the proper chair. It's going to give us the proper prisoner, okay? And if S is greater than 1, then we have to account for the shift away from S, all right? So in this case, the shift away from S is going to be 2. Now we take the total number of candy, which is going to be 7, right? So we have so we have 2 plus 7 is going to equal to 9. Now we take 9 mod 3 is going to give us 0. But we know that the reason that it gives us 0 is because we're actually looking at chair number 3, right? Because 9 mod 3 gives us 0, which is, or if you said 9 divided by 3 would give us 3, right? So we know that we're at chair number 3. That's the reason why we're accounting for that 0, because when we mod things, rather than giving us the actual numbers from 1 to whatever number of prisoner, we're going to get a 0, but that 0 just represents the last prisoner. So I hope this makes sense. So we're going to have 3, right? So our final answer here is going to be 3. And if we go down here, it's going to be 3 here. Okay. So with that said and done here, we have our base case here to just check to see if the number is 1, S is 1, and if S is not 1, then we take care of our shift. And yeah, so this is it for this problem. Let's go ahead and run the code. And that works. And let's submit. All right, guys, this will be it for this problem. I hope you guys enjoyed it. I'll see you guys on the next problem. Have a good day. Bye-bye.